Two fruit trees can stand in the same soil, under the same sun, receiving the same water, and still have completely different futures. One survives drought, the other slowly dies. And if you walk past them, you might think the stronger one was simply healthier. But the real difference is underground. It's the roots. Most people think fruit trees survive because of watering schedules, fertilizers, or soil quality. Those things matter, but farmers who have worked through dry seasons for generations know something deeper. They know survival starts before the tree is even planted. It starts with the rootstock. If this helps, you can subscribe. Let's continue. Imagine planting a fruit tree in your backyard. You water it carefully during the first year. The leaves grow, branches spread, and everything looks promising. Then one summer arrives hotter than usual. Rain becomes rare. The soil begins to dry out faster than you expected. At first, nothing seems wrong. The tree still looks green. Then, slowly, leaves begin to curl. Fruit drops early. Growth stops. And by the end of the season, the tree is alive, but struggling. Now imagine another tree planted just a few meters away. Same soil, same sun, same drought. But this one keeps growing. Not quickly, not dramatically, just steadily. Its leaves stay firm. Its branches hold fruit longer. Its roots keep finding water hidden deeper in the ground. The difference isn't luck, it's the rootstock. To understand this, we need to understand something simple about fruit trees that many gardeners never learn. Most fruit trees are actually two plants combined into one. The top part, the part that produces fruit, is called the scion. The bottom part, the root system, is called the rootstock. And while the scion decides what fruit you eat, the rootstock decides whether the tree survives. This idea is not new. Farmers in dry regions have known it for centuries. In parts of the Mediterranean, where summers can be long and rain can disappear for months, growers learned early that some root systems could reach deeper moisture than others. They didn't always know the science behind it, but they knew the results. Trees grown on strong rootstocks survived drought years. Trees grown on weak root systems did not. That knowledge was passed down quietly from orchard to orchard. Because when water becomes scarce, roots become everything. Think about soil during a drought. The top layer dries first. This is where shallow roots live. When moisture disappears there, trees that depend on surface water begin to suffer quickly. But some rootstocks grow differently. Instead of spreading mostly near the surface, they send roots deeper into the ground, where moisture remains longer. Even when the soil above looks dry and cracked, the deeper layers still hold life. And that's where drought-resistant rootstock finds water. A farmer once described it in a simple way. He said, during a dry year, shallow roots ask for water. Deep roots go find it. That difference determines whether a tree pauses its growth or loses entire branches. Modern orchards still use this principle, even when irrigation systems exist. Because irrigation can fail, weather can change, water can become expensive. But a strong root system continues working silently underground. And that silent work protects the tree. One example often mentioned in orchards is apple rootstock known for drought tolerance. Some root systems grow aggressively downward, anchoring the tree and allowing it to pull moisture from deeper soil layers. Even when rainfall becomes unpredictable, those trees remain stable, not immune to drought, but far more resilient. This resilience doesn't always show immediately. In wet years, all trees look similar. But drought reveals the difference. It exposes which trees were built to survive. And this is why experienced growers often say something surprising. They say the most important decision in planting a fruit tree is not the fruit variety, it's the rootstock. Because fruit quality matters only if the tree lives long enough to produce it. In backyard gardens, this idea is often overlooked. Gardeners choose fruit varieties based on taste, color, or harvest time. But farmers, especially those who remember dry seasons, often choose roots first, because roots decide survival, and survival decides harvest. There is something interesting about drought that most people don't notice. Drought rarely kills a tree suddenly. It weakens it first. Growth slows, leaves become smaller, fruit production drops. The tree begins conserving energy instead of expanding. And once a tree becomes weak, other problems follow: pests, disease, branch dieback. But when a tree is growing on drought-tolerant rootstock, this slow decline often never begins, because the roots keep working even when the surface soil looks lifeless. In traditional orchards, farmers often selected root systems from trees that had already survived harsh conditions. If one tree continued producing fruit during dry years, growers paid attention. They saved root cuttings. They grafted new trees onto those roots. They repeated the process generation after generation, not because it was fashionable, because it worked. This is how drought-tolerant orchards were built long before modern irrigation systems existed. In many regions, especially where rainfall was unpredictable, trees grown on deep-rooted stock became the foundation of reliable harvests. It wasn't about producing the biggest fruit, it was about producing fruit every year. You can think of rootstock as the survival system of the tree. While branches grow toward sunlight, roots grow toward water. And the stronger that system is, the more stable the tree becomes. Some rootstocks are naturally better at exploring soil. They grow thicker roots. They push deeper. They tolerate dry conditions longer. Others remain shallow and depend heavily on regular watering. Both can grow fruit, but only one handles drought with confidence. There's another reason drought-tolerant rootstock matters: soil temperature. During hot seasons, the upper layer of soil heats quickly and loses moisture faster. Shallow roots sit directly inside that stress zone. Deep roots stay in cooler, more stable soil. That stability protects the tree's internal water balance, and that balance keeps leaves functioning, fruit developing, and branches alive. Even modern agricultural research confirms something farmers understood through experience. Root depth directly affects drought tolerance. Trees with deeper, stronger root systems recover faster after dry periods and maintain more consistent growth. It's not magic, it's biology. But this doesn't mean rootstock makes a tree invincible. Even the strongest root systems need time to establish. Young trees are always more vulnerable to drought, no matter what rootstock they grow on. This is why experienced growers focus heavily on the first few years after planting. Mulch is added to protect soil moisture. Watering is done deeply but less frequently. The goal is to encourage roots to grow downward, not stay near the surface. Because once roots go deep, the tree becomes far more independent. There's a quiet moment in every orchard when this transition happens. At first, the tree depends on the grower. Later, the grower depends on the tree. And that moment is decided underground. One orchard owner once explained it simply. He said, "The day I stopped worrying about watering my trees was the day their roots reached deeper than my shovel." That's what drought-resistant rootstock helps achieve. A tree that can search for water beyond the reach of daily care. And this is why farmers often think years ahead when planting fruit trees. They don't just plant for the next harvest, they plant for the next drought. Because drought is not rare anymore, it's expected. And trees prepared for it continue feeding people when others fail. So how does someone actually use this knowledge? It begins with a simple shift in thinking. Instead of asking, what fruit do I want to grow? The better question becomes, what roots will keep this tree alive? Because the fruit variety you choose matters only after survival is guaranteed. When nurseries sell fruit trees, rootstock is often listed in small print or not mentioned at all. Most home gardeners focus only on the fruit type: apple, peach, citrus, pear. But experienced growers look for something else first. They look for the root system behind the tree. In dry regions, certain rootstocks are known for sending roots deeper into the soil. These trees grow a little slower in the beginning, but they become stronger over time. And strength matters more than speed when water becomes limited. This is especially true for fruit trees planted in backyard gardens where watering is not always consistent and soil conditions vary from place to place. A tree with shallow roots may depend on perfect care. A tree with strong rootstock can tolerate mistakes. That difference reduces stress not just for the tree, but for the grower too. There is also something else rootstock quietly improves: longevity. Trees growing on drought-tolerant root systems often live longer because they experience fewer cycles of stress and recovery. Their growth remains steadier across changing seasons. And steady growth produces reliable harvests. Not just once, but year after year. If you walk through older orchards, you'll sometimes notice something surprising. The oldest trees are not always the largest, but they are often the most stable. Their trunks are strong, their branches balanced, their fruit production consistent. Those trees survived years when rain didn't come. And they survived because their roots were prepared. Drought doesn't announce itself dramatically at first. It arrives quietly through weeks without rain, warmer nights, and soil that dries faster than expected. But trees growing on strong rootstock respond differently. They slow down instead of collapsing. They conserve energy instead of losing leaves. They endure instead of failing. That quiet endurance is what farmers value most. And this is why rootstock selection has always been part of long-term orchard planning. Not because it changes how fruit tastes, not because it makes trees grow faster, but because it protects the future harvest. There's an old idea in farming that still holds true today. You don't plant a tree for the season you're in. You plant it for the difficult seasons you know will come. Rootstock is part of that preparation. It's the hidden decision that determines whether a fruit tree depends entirely on you or learns to survive on its own. So the next time you see two fruit trees growing side by side, remember something simple. What you see above the ground is only half the tree. The real story is happening below. And sometimes survival is decided long before drought ever begins.